This technique is liquid-liquid extraction. For this you'll need a separatory funnel, a stopper for the separatory funnel, an iron ring to set the separatory funnel in. The setup for this experiment is that we have a significant quantity of an inorganic salt, in this case copper sulfate, which is blue, which is extremely water soluble, but not very soluble in organic solution. Here what we have is 9-fluorinone, an organic compound that is extremely soluble in most organic solvents, but not so soluble in water. If you take those two, if the two samples are mixed together, what you get is a greenish mixture that contains both visible blue spots and visible yellow spots. You could, tediously, mechanically separate those, but there's a smarter and better way. I have now added dichloromethane to the separatory funnel, and you can see the yellow solution sitting on top of mostly blue copper sulfate. I have now added a significant amount of water on top of the dichloromethane, and I shook it up vigorously such that the two layers mixed, and they have now separated. So what you can see is largely on top we have a blue aqueous layer with copper sulfate in it, and below that is a dichloromethane layer containing the 9-fluorinone. For reference, we'll use a slightly different mixture of solvents this time. I'm first going to start by adding the water and then the organic solvent. You can see a slight greenish tinge to this water, largely because of the yellow solid that's floating nearby, but the water has dissolved the copper sulfate. Next I'm going to add ether and shake it up again. In this case, the organic solvent sits on top of the water, so you can now see the 9-fluorinone dissolved in the ether and the copper sulfate dissolved in the water below. Proper technique on separatory funnels. Put the stopper in. Hold the stopper in place with your hand. Put it upside down and swirl, trying to mix the two layers. Every so often you need to vent in order to relieve the pressure, and then swirl and vent. Depending on the solvent, you can shake vigorously, but sometimes that's risky. Sometimes that can lead to an emulsion. In any event, once you have shaken it up, you can then set it down and let the layers separate out. Here's a close-up on those layers separating back out. You can see a line of bubbles that slowly resolves until you have nice, clean layers. I now have placed both separatory funnels right next to each other, and there's something interesting here that I want to point out. In both cases, the water layer, the aqueous layer, the aqueous phase, is the layer that contains copper sulfate, and therefore is blue. And in both cases, the yellow layer is the organic phase, and that contains the 9-fluorinone and is yellow. The difference between the two separatory funnels is that this one contains dichloromethane, and this one contains ether. Most organic compounds, much like oil, tend to float on water because they are less dense than water. And so this is the normal view of a separatory funnel, if you will. Organic sitting on top, aqueous sitting below. However, when you have dichloromethane or other halogenated solvents like chloroform, they tend to be more dense than water and thus sit below the water layer. The whole point of performing an extraction is to separate compounds in one phase from another. And so in order to do that, you need to have a nice clean phase cut between the two phases, the aqueous phase and the organic phase. If you have a nice clean line like that, then it becomes possible to drain out one in the presence of the other. So what I'm going to do here is drain off the organic dichloromethane layer, and I want to make sure to stop draining the organic layer before any of the aqueous layer goes down below. So once you get close to the end, you then make particularly careful that you haven't transferred any of the wrong layer in there. So what you have now is basically just the blue aqueous layer, no organic layer there. When it comes time to transfer stuff out of the separatory funnel, what you always do is pour it out the top. Stuff in the bottom of the separatory funnel you drain out through the stopcock. Things in the top of the separatory funnel you pour off. And again, you're trying to make sure that the two layers don't mix, because the whole point is to separate the two layers from each other. So what I now have is blue aqueous, yellow organic. When doing the other one, you can do the same thing. I will just put the blue aqueous layer below, and I will now drain out the aqueous layer. You will find that your separatory funnel does not drain if you have a stopper on. So make sure that you have the stopper off. When you open the stopcock, it will drain. And you can watch this phase line coming down, and I drain pretty quickly until I get very, very close down here. And then I back off on the flow rate until things are behaving themselves. And again, what I'm trying to do is minimize the amount of mixing between the two layers when I go to separate. So now I slow down. And I'm doing this a drip at a time, and it becomes fairly easy to stop this right where I need it to. Blue aqueous layer, and again, top layer goes out the top of the separatory funnel. And that is how you separate an aqueous soluble compound from an organic soluble compound. Liquid-liquid extractions.